Okay, so here we are, seg number 8. This one, notice that the calculator is allowed. Okay, so we're going to be able to do some things on the calculator. We don't want to do everything on there, but we can do some things. The first problem here, we're talking about a particle, and we're given its velocity for t values greater than 0. The first thing we want to do is find the position, right? So I don't know if you remember from before, if we were given some position function, call it s of t, then s prime of t, the derivative of that, gave us the velocity. And then s double prime of t gave us the acceleration, right, which is the same as the derivative of the velocity. So now we're going backwards, right? We're given the velocity, and we want to find the position, which, remember, that's like an antiderivative, right? Going backwards derivative. So really what we're trying to find is the integral of the velocity, right? So we're going to try to integrate both sides. Right now, this information should just be disregarded, like not completely disregarded, but just let it leave there, or let it stay there for a second. And so we're going to integrate. Remember, if we integrate velocity, we get position. We can call that s of t. I shouldn't use an s because it looks like my integral symbol. So let me call my position function x of t, right? That's another way to write it, x of t. Integrate this, you're going to get t to the third over 3, which cancel that 3, minus 44t squared over 2, which is 22t squared, plus 105t, plus what? Plus c, right? And so this is a key thing here, right? Like, to actually know the position, I need to know what c is, right? And so that's where this piece of information helps me. I know that if I plug in 0, I get 0. Notice, like, they're using an s, right? I changed it to an x just so you could understand what I was saying. So basically, I'm saying x of 0 is 0, meaning if I plug in 0, I should get 0 out, right? So this is saying x of 0, right? Plug in 0, we're going to get 0 cubed minus 22 times 0 plus 0 plus c, right? Like, everything cancels out, and we should be getting an answer of 0, right? When I plug in 0, I should get 0 out. And so all these things go away, and you're left with c equals 0. So in this case, our c value is 0, and so we can write our actual position function, which is just this, because our c was 0. So technically I could write plus 0. Like, if I would have got c as 5, I would have written plus 5 over here, right? But I got 0, so I leave it like this. Now this piece of information wants me to know, it's asking find the position at t equals 5. So I actually need to find x of 5, and this is where you don't need to do this by hand, you just do a calculator, right? So we're going to do 5 cubed minus 22 times 5 squared, plus 105 times 5, and it's going to give us 100, right? So the position is 100. At 5 seconds, the position is 100. It also wants me to say, so this is part A, right? It also wants me to find the velocity at time equals 5. Well, that's just v of 5, which is plugging in that to the velocity function. So 3 times 5 squared minus 44 times 5 plus 105 is negative 40. It wants the speed, which, remember, speed is absolute value of velocity. So it's just the absolute value of negative 40, which is 40. And then it wants the acceleration, which we're going to need to do a little bit of work for that, right? Acceleration is the derivative of velocity. So we have this velocity function, v of t equals 3t squared minus 44t plus 105. We're going to take the derivative, right? To find the acceleration, we take the derivative of this guy with respect to t, and we get 6t minus 44. And we want to know the acceleration at 5. We're just going to plug in 5. This one you don't really need to calculate. 30 minus 44, negative 14. Right? And so there's all those pieces. Next one. The particle moves along a coordinate line. Again, we're talking about motion. It's acceleration. We're given the acceleration. For each problem, find the position, velocity, speed, and acceleration at the given value for t. Okay, just one second. Okay, so I forgot to change this, but it will be changed on the exact on the test. I'm just going to change the instructions on here, and we'll do that. All this one's going to want is it's going to say find the velocity function. Right, so it's going to ask what's the velocity function. Right, we're given this acceleration function. You're not going to be given this anymore, and you're not going to be given that. It's just going to say find the velocity function. Right, so again, we're basically just trying to integrate both sides of this. Right, if we integrate acceleration, we get velocity. We're integrating using our normal rules. It's going to be 6t squared over 2 plus 56t plus c. And then, simplify a little bit just to make our calculations easier. And what this condition says is if I plug in 0, I should get out negative 196, right? So what we're going to do is we're going to plug in 0. So this is negative 3, 0 squared plus 56 times 0 plus c. We should get negative 196, which because we're plugging in 0, that goes away and that goes away, and you're left with c is negative 196. And so the velocity function is negative 3t squared plus 56t minus 196. It is very important that you write it like this. And not just circle c, right? You actually need to write the velocity function like such. Okay. Let's go on to the next one. It says a particle moves along a coordinate line. Its acceleration function is given. For each problem, find the displacement of the particle and the distance traveled by the particle over the given interval. Okay. So this one might not always give you an acceleration function. Okay, it might give you a velocity function sometimes as well. But the key thing out of this that you want to know is that if you integrate velocity from A to B, right? If I integrate velocity, I get position. If I put in some limits of integration, basically what this turns in is s of b minus s of a, right? Because if I integrate velocity, I get the position function, and then I plug in b and plug in a. This right here is basically the displacement, right? If I like the change in position, like how far was it between, s of b and s of a. So what I need is a velocity function, and then I need to integrate it from a to b. I'm not given a velocity in this, right? I'm given an acceleration, so we first need to find the velocity function, which means integrate it. So that's going to be 6t squared over 2, which is 3t squared, minus 44, plus c. And then we're going to use our initial condition again to find the value of c. If I plug in 0, sorry, there should be a t right here. If I plug in 0, I should get 121. Therefore, c is 121. So my velocity function is, right, c is 121. Please be careful, you won't always have 0, right? Like sometimes it'll be something else, like a 1, in which case that requires more math. This is my velocity function. I want to know the displacement, so I need to do the integral from 1 to 9 of 3t squared minus 44t plus 121 with respect to t. It's a 9 up there. And like you're not expected to do this by hand. Like you can just do this with the calculator, right? So let's get out our calculator and let's just do this on our calculator, right? So we can do math 9. That gives you the integral. We're going to go from 1 to 9 of 3x. Oh gosh. You know what I'm gonna do? I'm gonna have to put this in again. So I'm gonna put the function under y1 just so I don't have to type it again at some other point, right? So 3x squared minus 44x plus 121. So I'm gonna put that there, and then I'm gonna go ahead and exit this screen. Go out here and say math 9. Go from 1 to 9 of alpha trace y1 dx. This is going to give me my displacement. So the displacement is negative 64, meaning we ended up 64 units to the left of where it was before. Please read the instructions carefully. It also wants the distance traveled. So remember, the distance is, if I want distance, that's going to be the integral from a to b of the absolute value of the velocity. Right, so I took the absolute value, and again, this is totally calculator problem. You can't just take the absolute value of 64 and say that's your answer, right? So in this case, we're actually doing 1 to 9 of the absolute value of this function, and we're trying to see what we get. So to do this on the calculator, we're going to do the same steps. Math 9. We're going to go from 1 to 9 still, but here I need to put absolute value symbol, so it's also the math button under it's right here under NUM. Number 1 is ABS, which is absolute value, and then we can just put our y1 there and dx, and you're going to get, ooh, it's taking longer than I thought it would. You're going to get 258.370, right? So that's the total distance that it traveled during that time, is 258.370 units. Right? Last piece here is write an expression that will find the average value. So the average value is not the average rate of change. It's actually like, if you want to know the average temperature, you're going to integrate the temperature of whatever you want to find the average value of, right? So you have some function here that you're going to find the average value of. So like if this was a temperature function, then you would get the average temperature. If this was like a velocity function, then you get the average velocity. If this is a position function, you get the average position. If this was a rate at which gravel is processed, then you would get the average rate. If it was the total number, like if it represented the number of people in line, then you'd get the average people in line, right? So you get the hint, right? So basically what we do is we just integrate. Again, this is a and b, so we're going to integrate from -2 to 0. We're going to multiply on the outside 1 over b minus a, so 0 minus -2, and we're going to integrate our function like such. And since we have a calculator, we're going to do this on our calculator, but let's go and clean it up first so our calculator doesn't get too confused. Just clean up that fraction on the outside, and we can write it like this. So 1/2 is 0.5, right? So I'm going to do 0.5 math 9 from -2 to 0, -3 e to the x dx. Calculator does it for you. You're going to get -1.296 or -1.297, depending on if you truncate or round, and either one is acceptable as long as you have 1, 2, 3 decimal places, right? All right, so that's that. You will not, obviously you have to memorize this, and you have to memorize that distance is the absolute value, displacement is just the integral, and all the connections between velocity and position and all that stuff.